Hello everyone, and welcome back to the channel. Today we're diving into a fascinating topic that often flies under the radar: geological uplift. You might think of the ground beneath your feet as solid and unchanging, but over long periods, it's incredibly dynamic. We're going to explore how the rates of this uplift have varied, particularly since the 1990s, and what that tells us about our planet. So what exactly is uplift? In simple terms, it's the vertical elevation of the Earth's surface in response to natural causes. Think of it like the planet slowly stretching or pushing parts of its crust upwards. This process is responsible for creating the majestic mountain ranges we see today, from the Himalayas to the Andes. But it's not just about mountain building. Uplift happens on smaller scales all over the world, constantly reshaping our landscapes. The forces behind uplift are truly immense. One major driver is tectonics. When tectonic plates collide, the immense pressure can cause the land to buckle and rise, forming mountains. Another cause is something called isostatic rebound. Imagine a huge ice sheet, miles thick, pressing down on the land during an ice age. When that ice melts, the land, freed from the immense weight, slowly begins to bounce back up. This is still happening today in places like Scandinavia and North America. Volcanic activity also contributes, as magma pushing up from below can lift the ground above it. Now, how do we even measure something that happens so slowly? Scientists have some incredibly clever tools. GPS, or the Global Positioning System, is one of the most important. By placing highly sensitive GPS stations in specific locations, researchers can track tiny changes in elevation over time, down to the millimeter. Another technique is satellite radar interferometry, or InSAR. This method uses satellite data to create detailed maps of ground deformation, allowing us to see how entire regions are rising or sinking. By comparing data collected over many years, we get a clear picture of the rate of change. What's really interesting is how these rates have varied since the 1990s. The data shows a complex and dynamic picture. In some regions, uplift has accelerated, while in others it has slowed down or even reversed, for example, in parts of Greenland and Antarctica, the rapid melting of ice sheets has led to an acceleration in isostatic rebound. The land is rising faster than before, as the icy burden is removed. This has significant implications, as it can affect local sea levels and even the stability of the remaining ice. Conversely, in other areas, human activities are playing a role. The extraction of groundwater, oil, and gas can cause the ground to sink, a process known as subsidence, which is essentially the opposite of uplift. In some coastal cities, this subsidence is happening much faster than any natural uplift, increasing the risk of flooding. Understanding these varying rates of uplift is crucial. It helps us refine our models of tectonic processes and climate change. For geologists, it provides insights into the Earth's deep interior. For communities, especially in coastal or mountainous regions, it's vital for assessing geological hazards like landslides and planning for a sustainable future. The data we've gathered since the 1990s has revolutionized our understanding and highlighted just how interconnected Earth's systems are. So the next time you look at a mountain or walk on what seems like solid ground, remember the slow, powerful forces at work beneath you. The Earth is constantly changing, and thanks to modern science, we can watch it happen in real time. Thanks so much for joining me today for this geological journey. If you found this topic as fascinating as I do, please hit that like button and subscribe for more content about our amazing planet. Let me know in the comments if there are any other Earth science topics you'd like to explore. See you in the next video.